Hi guys, Buildzoid here, and today I'm going to be explaining the LGA1700 washer mod because it's been picked up on by the internet at this point. I haven't figured out how to make a video about this, but I've seen a lot of other people cover it at this point, and they haven't done a very good explanation, good job of explaining why, when, and how this modification works. And so we're going to get into that, because obviously there was a process that led me to figure out, that led me to trying this, and there's a reason why it works for me, and there's a reason why in many situations it will not work. I can tell you for a fact that with in a lot of scenarios, I wouldn't expect this to do anything at all. There is a lot of situations where doing the washer mod will not give you any improvement, and that's fine. Because it's not meant, the mod is meant to solve a problem that I ran into that is kind of my own creation. So, first of all, what is the washer mod? Basically, you just put washers under the loading mechanism, under the parts of the loading mechanism on the LGA1700 socket. And so these are the washers I used. If you're going to use metal washers, and they're made from stamped sheet metal, make sure that the sharp edge is upwards and not towards the board, right? You can see how this edge has a bit of a glint to it. That's because that's the sharp edge of it. So if you have stamped metal washers, make sure that the sharp edge isn't going towards the PCB, because that can damage the solder mask and potentially cause a short circuit. You might also, what I'll probably do in the future with my board is actually put some electrical tape under that, just to make absolutely certain that even the smooth side of those washers doesn't start harming the solder mask. The solder mask on modern motherboards is pretty hard, especially this matte one. It's pretty robust. It takes some effort to get through it, even when you want, even when you're intentionally trying to get through it. So that's one thing. You can also use plastic washers. And so, yeah, you just put washers under the top side of the bracket. You can see that there's one washer sticking out under the lower side of the bracket. And you want these washers to be a millimeter thick. And all this really does is it reduces the amount of pressure that the loading mechanism applies to the CPU. And the problem this is trying to solve is a mismatch between the shape of your cooler's cold plate, or contact surface, right? The part of your cooler, be it an air cooler or water cooler, that makes contact with the CPU. You can have a mismatch between the shape of that surface and the shape of the CPU. And you can very clearly see that that's what I was fixing with the modification for me, because this is a, even thermal paste spread. I mean, it's kind of thin towards the edges, but this is mostly even. And, if you apply a cool, and this is how I apply thermal paste pretty much anytime I actually care about getting good thermal performance. It's worked great for me in the past. This is this works fine. I've done a lot of testing on thermal paste applications, way more than is really sensible. This works fine. Okay, there's people who are this gets air bubbles. They're wrong. With how much pressure your cooling system applies to the thermal paste, you don't get air bubbles. They just get squeezed out. Anyway, so yeah, after mounting the water block that I was using, I ended up with a thermal paste pattern that looks like this. And the obvious problem we have here is most of the thermal paste is at the center of the CPU. Right? That's not what we want to see. The hottest part of the CPU is right here. And also, I think I might have screwed up something in... Okay, I haven't. Oh, I removed my extra layer. That's what I did. That's why I didn't notice anything. Anyway, yeah, so the hot part of the CPU is right here. So having all of the thermal paste above the hottest part of the CPU, not ideal for your temperatures, right? Not ideal for your temperatures whatsoever. For comparison, and I keep doing that, for comparison, here's just, a blob of thermal paste down the middle. You still see the same effect. It doesn't spread out properly. Most of the thermal paste is still stuck in the middle of the IHS. Now, why does this happen? And there's two parts to this. So one, we need to look at how so we need to think about how this loading mechanism for the CPU works, and also about the shape of the IHS. But we're going to assume, this is unrealistic, but we're just going to assume that the IHS is actually flat. It's not, but let's just say it was flat. Anyway, so this part right here, right, that's that's like the lip of the CPU that the loading mechanism actually interacts with. Then this is our substrate. So I'm just going to put sub on that, or there. So that's our substrate. Then we've got the pins in the socket, right? And these are like little springs, and they actually, there's our pin. God damn it. There we go. We got some pins in there. All right, so our CPU is sitting on top of the pins, and I'm just including the fact that like these pins are in that orientation, these pins are in that orientation, right? And so that's just how the pins are arranged in the socket. And there's a good reason for that, because the pins are actually springs. So even when the CPU is just resting on the pins are actively pushing up on it. Not very much, because, you know, the weight of the CPU isn't really going to compress the springs very much, which is why, like, if you try to boot a motherboard with the CPU just sitting in the socket, it's not going to work. It's probably not going to have, like, some of the pins are going to be slightly lower. Like, the whole reason this is done this way is because you want to press the CPU down onto the pins, and because the pins are springs, they're not all going to be the same height from the factory, so you press the overly tall pins down, and the lower pins will eventually make contact, right? And since they're all little springs, they're all going to be pushing up on the CPU a little bit. And then we put the loading mechanism over the top of this, right? So I'm just going to draw the, like, really badly draw the loading mechanism. And that's just going to go over like that. And then we have that, like, pin thing at one end, right? Actually, they changed that. There's now, oh, right, I'm drawing, like, the LGA1700, the 1100 loading mechanism, not the... So actually we have like another part that, you know, clamps down on this. You have that lever piece that locks that into place. Anyway, and then there's like one right down the middle of the CPU is where we have those actual, like, mounting, like the tabs, right? So that's these things. And those actually press the CPU into the pins. Now, the problem with this is that this is pressing on the CPU right down the middle. The pins are pushing up on the CPU uniformly, right? So we have a bit of a mismatch here in terms of forces, right? Like this corner is gonna start going up, and our IHS, which in a perfect world would be flat, is gonna end up looking like, let's say we did start with a perfectly flat IHS. We almost certainly didn't, but let's say we did. Is gonna look like this, right? Like, it is gonna curve. So we're just gonna say it's now curved, like. Oh man, I can't draw curves. I give up. It's curved. Screw it. So the IHS is going to deform to make a curve, something like this, because the pins are pushing up against the CPU, and the loading mechanism is pushing down on the CPU, but only literally right in the middle. Now, LGA2000 CPUs, right, so like X299, X99, X79, these don't have this issue, because the loading mechanism works differently. Instead of pushing down on the CPU right down the center, those apply pressure to the CPU on the edges. And actually, that's why those CPUs will have a lip that extends like that. And then the loading mechanism, you know, presses down on that. And those CPUs actually do the opposite thing, where the center goes up, because the pressure is applied at the bottom and top edge. And so the center rises, you know, so those CPUs end up looking like this a little bit. But the LGA2000 mechanism is pretty expensive, and so Intel doesn't want to use it on LGA1700, because LGA1700, as expensive as it is, you know, does have like H610 motherboards for OEMs, and those OEMs are going to be very upset if they need to spend like 50 cents more on their socket mechanism when they're building a Office PC, you know, trash computer. So that's kind of why we have the LGA17 mechanism working the way it does. It needs to apply, you know, like there's a spec for how much pressure Intel wants to apply to each of the pins to have reliable, you know, like memory, like, because you need, there's a certain amount of pressure you need to apply on the CPU so that you have good contact with the pins, so that like PCIe Gen 5 and memory works and DDR5 work properly. But at the same time, they don't want to spend the extra money on a more complicated loading mechanism, because H610 based, you know, trash computers have to exist, and those manufacturers don't want to pay for a better loading mechanism. So you get like a socket where you're trying to apply like LGA2000 levels of pressure to the CPU through a mechanism that really doesn't do a very good job of that, and that curves the CPU. Now, this is normally not an issue, funnily enough. This normally isn't an issue because heatsink manufacturers are very much aware that Intel CPUs come with IHSs that look anything for some generations, it was really common to see something that looks like this. There are some CPUs that look like this. That would be like the HEDT, right? HEDT tends to do this, which, like, that's mostly because of the way the socket interacts with it. This is like, I think I had a lot of 1150 CPUs that would have like tall corners, tall middle, and then like a low section in between that. LGA1700 generally looks like this. I think from the factory, I've not checked a fresh CPU. There's a pretty decent chance that after you put a LGA1700 CPU into the LGA1700 socket, it gets deformed permanently, right? Like, I don't know how springy the IHS is. Like, and also depending on how long it's been crushed for, it's gonna start taking on that curved shape more and more. So I'd imagine after a few years, you're gonna have some very U-shaped CPUs out there just thanks to the loading mechanism. Anyway, so IHSs just come in all wonderful shapes, just not flat. They definitely are never flat. I've never seen a flat... Actually, no. Well, not Intel. I've never seen a flat Intel CPU. I've seen, like, occasional flat AMD chips, but Intel, never. I've never seen a flat Intel CPU. Now, water block manufacturers and heatsink manufacturers have realized that there's an easy fix for this. Just make your cooler curved. Right? Because if you have if your heatsink is curved, because if you think about it, like the die is going to be here under that IHS, right? Or here and here. And so from a cooling perspective, like, who cares about this? It doesn't matter, right? Who cares? Doesn't matter. The important part is right here. This is where all the heat comes out. This is where it's absolutely critical that you get as much metal on metal contact as possible. And so if the CPUs have all kinds of lovely shapes that aren't flat, then the logical solution to the problem is to make water blocks and heat sinks with curved bases. And this is like exactly what happens. If you check any Asetek AIO, it's going to have a curved base. It's not going to be very curved, but it's going to have a very slight, it's going to have a curve. Same for every EK water block that I've ever used. From the factory, they come with a curve. Every air cooler that I've ever used, they come with this curve to them because IHSs are not flat. And so if you always make your, if your heatsink always has this shape, so if your cooler always has this shape, well, if I take this shape and I shove it in here, right, assuming that the curve is significant, we're gonna crush that thermal paste just fine right above the IHS. Like right above the die, we're gonna crush that thermal paste great. If we do that on here, same thing. Like, sure, we're going to be losing a little bit over here, but we're still, and also if you apply enough mounting pressure, you can actually deform the IHS to conform to the curvature of the water block to some extent. So yeah, you can just bend the CPU back like into the shape of the water block with enough mounting pressure. And so you just sort of crush, so this works out just fine. Same goes for HEDT, right? It might be more optimal if we actually had a flat water block on HEDT. That might actually work out a bit better. That could get a slightly better contact. But ultimately, this isn't going to be a disaster. And again, if you apply enough mounting pressure, that curve is going to flatten out a bit. In fact, I have a EK water block that I used on like an X79 motherboard for several years. That block is flat. It came with a curve. It's flat now. Because, multiple years of just being cranked down on that CPU, the materials slowly drifted into a more, like a shape more matching of what it was crushed up against. And so now it's flat. Because I think the CPU, actually I don't think I lapped that CPU. Maybe I did, I can't remember. Block's flat either way, like it doesn't matter. Also the mounting bracket obviously, like the water cooler mounting bracket obviously applies all of its mounting pressure at the outer edges, so yeah, it's going to slowly overcome the curvature that the block comes with from the factory. And so, if you have a significantly curved cooler, the washer mod isn't going to do anything, right? Because if you have a very curved cooler base, this is fine. Right? Like a curved CPU with a curved cooler, no problems. But the reason why I came up with the washer mod is because I was seeing this. My water block is not very curved. And there's a very good reason for why it's not very curved. I've lapped that water block. because it's a water block that I use specifically, like it's a water block that I've dedicated to liquid metal usage. And one of the easiest ways to remove liquid metal residues is to just lap them off. And so that block's been lapped a few times, and consequently, it's very flat. It's not completely flat, but it is way flatter than like the Asetek AIO that I've been using with my 12900K up until the point where I decided, you know what, I really want to see what happens if we try like way more cooling, liquid metal, just throw everything at cooling the CPU. And so I pulled out this water block that I only ever use with liquid metal, and I was getting absolutely god-awful temperatures, and I was sitting there very confused why this wasn't working. And so then I did these tests with the thermal paste, and I was like, oh, okay. Is there some way I can make the CPU less curved? So my water block, right? So BZ's block, which is flat, doesn't have to deal with this problem right here, because it's just not going to work in that scenario, as you can very clearly see from this. So, raising up the loading mechanism, right? If we raise this and we raise that, we reduce how much pressure this is pushing down with. So if we push down with less pressure over here, because basically what happens is the more, like if I apply a ton of pressure over here, right, just an absolute ton of pressure, we're going to bend the CPU, like the CPU is going to bend like this. But if we apply less pressure, it's going to bend less, right? Very simple physics, because ultimately the pins are always going to be pushing up against the CPU. And also, like, the Igor's Lab did an article about how the LGA1700 socket actually bends the entire motherboard, which it does do that, and it does happen less if you do the washer mod, but that's not necessarily going to, like, improve your thermals. And I've seen some people go like, hey, what if you kept the motherboard perfectly flat? Would that make the washer mod less useful? Well, no, because the pins are still capable of bending the CPU. Right? Like the pins are springs. They push up on the CPU. So even if the board was perfectly flat, the CPU is going to get deformed against the pins. And I would imagine if after like a few years, we could probably see LGA1700 sockets to actually have like the middle pins of the socket would, maybe not even a few years. Like I don't know how long it would take, but I would assume if you have a LGA1700 socket with its standard mounting pressure, the pins in the sort of center section, right? So the ones in like this area, I would imagine they'll end up like a few fractions of a millimeter lower than the rest of the pins in the socket. And that leads to the potential issues with the washer mod. So, like it's perfectly safe. Like if you use metal washers, there's the risk of scratching up the solder mask. You can use plastic washers, and that's not a problem. You can also just put electrical tape under the metal washers, and that'll solve that as well. But potential issues are, Intel spec that insane, like, loading mechanism pressure because they want good pin contact so that you can run high memory speeds, PCIe Gen 5, all of these things where, getting good contact is absolutely critical. If you have dodgy contact on, like, a memory channel or, like, a memory data line, you are, like, that memory channel might not even initialize, right? So that leads to the issues. So so basically what can happen if you try this modification is you might have memory detection issues. I've not run into that. Then again, I've maybe not had my CPU loaded into an LGA1700 socket for long enough, which I don't think is true. Like, I've had that CPU sitting in some motherboard basically since I've had it. Then again, I've also not really, like, I've been mostly using the air cooler that just sits on top of it with gravity, so maybe the fact that I haven't been cranking down full, like, mounting pressure on it, maybe that sort of helped with keeping the CPU relatively flat-ish, or at least the sockets flat. I don't know. Right? I have one my sample size is 1 here, so there's a lot of complex interactions happening here between the pins, the IHS, the substrate of the CPU, and the loading mechanism, and I don't have a good way of testing all of that. But what I do know is, in my case, with my very flat water block, reducing the loading mechanism pressure helped CPU temperatures a lot. Like, it was night and day. I went from thermal throttling to, running benchmarks at the highest CPU clocks I've ever seen with my 12900K. Like, I went from struggling to go past 5.2 gigahertz in Cinebench to benching at 5.3, to doing Cinebench at 5.35. Very, very big difference for me. But my block is flat, right? Relatively speaking. And I imagine if you have a, factory condition water block from like EK or just an Asetek AIO, you do this modification, it's not going to do anything. Like, I'm pretty sure it's potentially not going to do much of anything at all. Right? And so that's kind of the thing to consider. Or maybe it will, right? Like, it is a very low risk modification in my opinion. Like, you just put some washers on there. And if it works, you might see a temperature improvement of maybe 5 degrees. And if it doesn't, then evidently there was a good match between your heatsink and the shape of your CPU, right? Like, that's the main thing, because that's all this is really trying to solve, is a mismatch between the shape of the CPU and my water block. And it might also, like, maybe there's some water blocks out there. Like, I imagine that each cooler manufacturer has, like, their own version of the most optimal cold plate curve. So some coolers might be slightly less curved, and those would actually benefit from this modification. And some coolers will be more curved, and those will care far less, right? Because the more significantly curved the water block or air cooler or whatever it is cooling your CPU is from the factory, the less susceptible it is to IHS deformity. Right? Because it inherently it's inherently optimized to have a very centered contact patch that's very, centered, I guess. And there's not really any other way to word that. So, yeah, hopefully this explains how and why and when this works. Like, this only works if your cooler is relatively flat, is flat relative to your CPU, and your CPU is getting deformed by a significant amount by the loading mechanism. If your CPU, which I think all of the CPUs are probably getting bent by the loading mechanism quite a lot, because all of the loading mechanisms are, like, it's insanely heavy. This is, I think, one of the heaviest loading mechanisms. Like, I don't like the LGA1700 loading mechanism. I don't like how much pressure it takes. Like, I've had the CPU jump out of the socket when I let go of the latch too quickly once. And this modification, reduces the problem. Like, it actually makes that not happen anymore. But if you're only installing the CPU once, I think maybe this is one of those things that might be worth testing if you're building a fresh system. Right, like really early on. I think if you've had the CPU installed for a while, and especially if you have, like a normal condition water block, I don't think it will really do anything. Now, if you have a fresh system, you could do like a first, like one run with stock mounting pressure, and then a quick run. And especially if you're on water cooling, here's a neat trick that you can use for sort of cheating thermal tests on water coolers. If you just monitor the temperature of the water, you can do a water temperature relative to CPU delta instead of CPU to air temperature, because CPU to air temperature requires that you actually have there's two ways to go about it. Either you wait for the thermals to stabilize, or it's obnoxious. So the easier way to do this is just go to the CPU to water temperature delta. If that is lower, then the modification worked, right? Anyway, where was I going with this? Yeah, so that's kind of that. So it's very situational. I don't expect this modification to work all of the time. If you've had your CPU installed for a while, it might cause contact issues, right? Because like I said, I think the pins will deform over time. So if you've had your CPU installed in a motherboard for a couple months at this point, then there's a decent chance that if you now reduce the loading pressure, it is gonna lose contact at the center of the socket, and your memory will not be detected, and that kind of thing. You might run into those kinds of issues if you do it after a while. But if you do it first thing, there's not really much to lose. Like, there's no warranty stickers on those screws. Just, be mindful of the fact that the socket has pins in it, and if you drop stuff on those pins, you're gonna have a bad day. But you could also, one of the things you could also do is just look at your heatsink, take a straight edge, rock the straight edge across your heatsink, because it's almost certainly going to be very curved, And if there's a significant curve on it, maybe not worth bothering with this modification in the first place. It might be kind of interesting to test how this modification interacts with like different manufacturers of coolers. But I would assume, like, I think with Asetek AIOs, this modification isn't going to do anything. Because those do come with a very significant curve from the factory, because that curve just sort of means you don't have to worry about, IHS condition very much. So, yeah, this video is way longer than it really needs to be at this point, but hopefully this covers everything that needs to be said about this. So, yeah, primarily... This is primarily helpful if you have a very flat water block. It's also very easy to test. It might cause memory and like PCIe issues, but it's also very easy to undo. And if you're just initially building your system outside of the case, it won't take you very long to... Actually, you could... I wouldn't really want to do this with inside a case with the... Well, okay, not with the system standing up. If you lay it down, it's going to be fine. So yeah, if you're just initially testing out your cooling system, then it might be worth checking if this helps you or not. If it doesn't help you, don't use it. If it does help you, well, use it. Like, there's really no harm to it. Also, the torque screws on this there's not much... They're not tightened down very hard, so... yeah, don't stress, don't crank down on them too much. I don't think you could really damage anything if you did, but they generally aren't very tight, because they don't need to be, right? Like, those are literally just there to make sure that the loading mechanism, fall off the motherboard. Anyway, I'm not gonna get into that. So, yeah, that's it. Hopefully somewhat helpful. Yeah, thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with Actually Hardcore Overclocking, I have a Patreon. And then I have Patreon. There's a Teespring store where you can get merch, and there's links to both Patreon and Teespring down in the description. It would be much appreciated if you'd check them out. And that's it for the video, so thank you for watching, and goodbye.